All right, hi guys. Today is your second lesson of College Algebra Chapter R. We are covering lesson R2, which is about subsets of real numbers. So please make sure you title your notes accordingly. Here is your warm-up for today. Again, you guys can pause the video, spend a minute or two answering the questions, and then check your answers with mine. All right, so negative 15 plus negative 19 plus 16. I would like you guys to try to do this in your heads without using your calculator. So negative 15 plus negative 19, we're going to add that. That becomes negative 34 plus 16 becomes a negative 18. 6 times negative x times negative 4. So two negatives multiply to give a positive. So that gives me 6 times negative x is negative 6x times a negative 4 becomes a positive 24x. Negative 9 times negative 2 gives me 18. That times negative 4b gives me negative 72b. Okay? And then number 4, so Kristen pays $1.90 per black and white photo. And then $6.80 per color photo, which we're calling C, to have some photos restored. What was the total amount, A, that she paid if she had 8 black and white photos and 12 color photos restored? So I'm going to go ahead and write this over here. So we know the total amount we're calling A is $1.90 times the amount of black and white photos she orders plus $6.80 per colored photo. Okay, and if we know the number of black and white photos that she ordered is 8, we can put that in for B, and then the number of color photos she ordered is 12. We can plug that in for C, which then becomes 15.2 plus 81.6, which ends up giving us a total of $96.80. So that is the amount that she spent. Okay, so moving on to today, we are going to classify what we call subsets of real numbers. So last class we were talking about what is a set. For math, it's a collection of numbers. So when we talk about the real number system, think of any number that you could visualize on a number line. Okay, any number on a number line. So positives, negatives, whole numbers, decimals, numbers that repeat forever, numbers that end, numbers that have a pattern, numbers that don't. The only non-real numbers are what we call imaginary numbers. Okay, so within the real numbers, any number that you can think of on a number line, we have different sets of numbers within those. Okay, so the ones we're going to learn about today are the natural numbers, whole numbers, integers, rationals, irrationals, and reals. This you don't have to write down quite yet because we're going to define them in just a second. And these are all numbers you're very familiar with. We're just going to actually formally define them today. So here are the natural numbers, okay? Natural numbers are the numbers that you can naturally count in nature. So if you're looking at something in nature, like a flower, you could see 1 flower, you could see 2 flowers, you could see 3 flowers. So starting at 1 and going up as whole numbers, okay? The natural numbers do not include 0. So go ahead and please write this down. Natural numbers are the set of all numbers starting at 1 and then going up in whole numbers, 2, 3, 4, 5, 6, 7, on and on to infinity. Okay, the whole numbers, the only difference is that the whole numbers now include 0. So it's the natural numbers plus 0. So whole numbers, you're pretty familiar with that, starting in 0, going up 1, 2, 3, 4, 5, 6, all the whole numbers that you can think of. Okay, integers, the only difference now with the integers is that they include negative whole numbers. Okay, so the whole numbers are all positive. And then integers include negative whole numbers. So you have 0, 1, 2, 3, 4, 5, etc. on to infinity. And you also have all the negatives, -1, -2, -3, -4, etc. Okay, rational numbers. Rational numbers are next. So a rational number is any number that can be written as a fraction or a decimal that terminates, so it ends, it stops at some point, or it repeats itself. Okay, so it can be written as some number divided by some other number. We could call those numbers p divided by q as a fraction, or it is a terminating decimal, so like 0.25 that ends, okay, or a repeating decimal like 0.7 repeating, because there's a pattern to that and it can be written as a fraction ultimately. Irrational numbers are non-repeating, non-terminating decimals, or numbers that cannot be written as a fraction. Okay, so an example of an irrational number would be pi, the pi symbol, which is approximately 3.1415926, etc., etc., etc. For pi, there's no pattern. So we have calculated billions and trillions of digits of pi, and there's still no pattern. So it's irrational because we can't really explain the pattern. So that's what I always think of irrational when you think of an irrational person. It doesn't really make sense, not super logical. Okay, so pi is one of those. Square root of 2 is another example. 1.14, etc. There's also no pattern to this. It doesn't repeat. It does not have a pattern. Okay, and then real numbers. Real numbers are the set of all rational and irrational numbers, because rational and irrational numbers make up all of the rest of these. Okay, so I'm going to show you guys a couple of diagrams that just show you how to actually display these subsets of real numbers. And this is something that, yes, you will have to memorize for the year. So here is our overarching real number system, okay? It represents this entire big box. Now, we're going to start with the smallest box here, the natural numbers, and then every box after that includes every single one of these. So the whole numbers include natural numbers. The integers include whole numbers and natural numbers. The rationals include integers, whole numbers, and rationals. So as you work your way up, these are all included. All right, so naturals, again, starting with 1, 2, 3, etc. Okay. The whole numbers, they add 0 to that. Okay, integers, you add the negatives. Rational numbers, we said fractions, terminating decimals, repeating decimals, okay? And then irrationals, those are over here on their own little playing field. So irrational numbers, we said like the square root of 2 or a lot of other square roots, or pi, numbers like that, okay? So within the real number system, we either have rational numbers or irrational numbers. And then within the rational numbers over here are all of these: integers, whole numbers, naturals. Okay, so please go ahead and draw this diagram. You can pause it if you need to. And again, these are all real numbers. These are all numbers that are on a number line. None of them are imaginaries. And if you want to actually add the full thing here, you can. Okay. All right, and then here's one more way of representing this in a circular fashion. Okay, so similar thing, natural numbers. Then whole numbers include naturals, they just add 0. Integers include both of these, they just add the negatives. Rational numbers here, and then irrational on their own little area over there. And all of these are in the real number system. Okay, And then last but not least, let's do some examples here. So list 5 numbers on your paper that are irrational. So for this, we can list pi, we can list square root of 2. Let's go ahead and you can pull out your calculator or something like that and test a couple of other square roots and see if those work. So I'm going to type mine in real fast. So you could put square root of 5. You could put square root of 7. You could put square root of 6. Okay, there are 5 of those. List 5 numbers on your paper that are rational. So let's think of some fractions or decimals that are rational. So 0 gives you 0.1, 1/4, 0.5 repeating, and let's do 0.7291. Okay, all those are either decimals that terminate or repeating or fractions. List 5 numbers that are integers, so positive and negative whole numbers. So -8, -2, 0. We could do 1, 4, 5. Oops, I listed more than 5. 1, 2, 3, 4, 5. There we go. Okay, and list 5 numbers on your paper that are whole numbers. So whole numbers do include 0. So we could put 0, we could put 1, and we could put 8, we could put 92, we could put 141. And then 5 numbers that are natural, so all the naturally appearing numbers in nature, so not including 0, so starting at 1, and then any of the rest of the positive whole numbers. So 4, 5, 86, 290, etc. Okay, lots of different examples. So these are all of our examples today. Just make sure, like I said, that you guys have this written down. Oh, and I realized earlier I made a mistake here. Square root of 2 is 1.41. I said that backwards, approximately 1.41 instead of 1.14. Okay, you guys can go ahead and get started on your homework.